All right, welcome teachers to Spark App League's teacher training. This is our third session, number 3, our third topic. Today we have some really special guests. We have one of our partners from ASU, Christina Karaskia. She is going to talk about design, but first we're going to hear from our collaborators at the Spark Lab from the Smithsonian. I have Trisha Edwards joining us today and Tim Pula. So I'm going to hand it over. They have a presentation that they're going to be showing you all about invention. And if you have any questions, feel free to stick around. We'll take questions both on YouTube and via the Google Hangout. So I'm going to switch it over to them. And Trisha, go ahead and take it away.
Hey there. Oh, thanks, Derek. So we're very excited to be here. As Derek said, I have my colleague Tim Pula here, but we only have one mic right now, so you're probably mostly going to hear my voice, but Tim may chime in later. So we're going to just dive right in and give you a little bit of background about what Spark Lab is, and then kind of our approach to invention education. So we are part of the Smithsonian Institution, which many of you might know is the world's largest museum complex. We have 19 museums, the National Zoo, and 9 research centers, and we look at everything, all different subject matters, history, art, culture, and the sciences, and everything in between. So one of those 19 museums is where Tim and I work. It's the National Museum of American History, which many of you might be familiar with. So we have vast collections, everything from the Star-Spangled Banner, our flag that inspired the national anthem, which you see there in that little thumbnail, Lincoln's top hat, and other presidential artifacts. And our most visited object is actually the ruby slippers. But what many people don't know is that the museum was actually founded in 1964 as the Museum of History and Technology. We only became the Museum of American History in 1980. And so because of our roots in technology and history, we have huge technology collections. So some of the original light bulbs, printing presses, telephones, from their first telephones all the way up to modern telephones, any kind of technology, computers, video games, anything you can imagine we have. And so that's actually a big reason why the center where we work is located here. So our full name is the Lemelson Center for the Study of Invention and Innovation. And people often think it's curious that there's a Center for Invention and Innovation at a history museum. Why isn't it at a science center or maybe the Air and Space Museum at the Smithsonian? And a big part of it is because of the museum's expertise and collections in the history of technology. So we do both kind of scholarly research on in the history of invention, and then the work that Tim and I do is really focused on how do we take that research and put it into programs and activities that are interesting and accessible to the general public. So we were founded in 1995 by this couple here. This is Jerome and Dorothy Lemelson. And I like to show this picture because Mr. Lemelson there on the left is actually one of the most prolific American inventors of all time. He's not a household name like Thomas Edison or Alexander Graham Bell, but he had over 600 patents and was invented in lots and lots of different areas. And so when he and his wife made some money from his inventing, they decided they wanted to set up a center at the Smithsonian to, again, both study invention and innovation, but also to engage the public in invention and innovation.
Hey, Trisha, sorry to interrupt you, but your slideshow is not showing.
It's not showing. Okay.
No, I'm only seeing the PowerPoint window with the thumbnails on the left-hand side.
Oh, that's curious. Okay, well, let me try this again. Are you still seeing that?
Now I'm seeing the PowerPoint window with the Lemelsons and still the thumbnails on the left.
But you still the thumbnails. Okay, I don't.
Do you have presenter view? Yeah, you have presenter view turned on, and I think that's what's causing it.
Presenter view.
There's a checkbox on the upper right.
Yeah, it's checked.
Yeah, I think that should be unchecked.
Unchecked? Oh, thank you. Okay.
And then try that.
Okay, how about that?
Whoop. Looks like.
What do you?
Nope, I still see the PowerPoint window.
Okay. Hold on. Let me try one more thing.
Did you share the whole display on Hangouts, or did you just share the window?
I don't know. Let's see. I'm clicking. I see what you're saying. Yeah. Let me try something else. Oh, gosh. I don't know what just happened there.
That's actually good.
That
Because
is?
now if you do the presentation, we should see the actual presentation.
Do you see it?
Nope. Now I just see the Google Hangouts window.
Okay.
Okay.
So yeah.
All right, let's switch back to the other one. Would it be possible for you to just walk through just by clicking on the slides on the left without the animations?
I haven't had any animations yet, so.
Okay, yeah,
Or I
so
guess
just back out of the presentation and just click on the slides on the left-hand side as you're going through.
okay, like that.
Yeah, because I can see that, our vision, our mission.
Yep. Okay.
Yeah,
Okay.
I can
Yeah.
see that.
Thanks.
So.
Sorry about that.
Yeah, no problem.
Yeah, at Smithsonian, we're actually not really set up to use Hangouts just because of security reasons. So it doesn't really surprise me that we're having a little bit of technical difficulty. So anyway,
That's okay. We can see the slides now, so we're
perfect.
good.
Okay, so
right.
just back to a little bit about the Lemelson Center. I won't read this to you, but I think what's really important is that first under vision, when we talk about a world in which everyone is inventive, that's something that if you spend any time with us, you hear over and over and over again, that we really, really firmly believe that while everyone might not become an inventor in their life, that we're all inventive. And so a lot of our work, particularly in the work Tim and I do, is really focused on how do we get people to be inventive and feel and understand that they are inventive. And so a big part of our work is really focused on Spark Lab. This is a picture of the Draper Spark Lab at the Museum of American History. This is a hands-on invention center where visitors to the museum, primarily children and their families, come in to engage in the invention process. So our you can see here's our kind of our mission statement just for Spark Lab. And again, you see in that first line, we believe everyone is inventive. And so Spark Lab is really about providing opportunities to create, innovate, collaborate, and problem solve. Because we know that these are the things that while they're really important to inventors and they help they're what make inventors able to do their work, they're also really important for whatever kids grow up to be. So, we're working with fairly young kids, primarily between the ages of 6 and 12, although we definitely get older kids than that, and grown-ups, of course. But we know that it's hard to predict what an 8-year-old might grow up to be, but we know that these are the kinds of things and skills and activities that will help them develop skills they need and confidence they need today and in the future. So Spark Lab, we've got 4 sort of big outcomes that we're looking at. And again, I won't read these, but I think, a couple things that are really important are it's really, Spark Lab is a very visitor-driven or child-driven environment. So that second bullet point about identifying problems, setting goals, and designing solutions, that's really about our visitors coming in and doing that. So we provide the context, but we don't tell them, we don't set the goals for them or design the solutions. That's really up to them. That third bullet point really talks about invention as a process, which is something else that you hear us talk a lot about. And the idea of how can we use Spark Lab as a place to build resiliency. So we don't focus so much on the failure, but when kids do fail, how do we help them beyond that? And how do we get them beyond that so that they can be resilient and come up with new solutions? And then finally, we really want them, again, to be able to see themselves as inventive thinkers and problem solvers, because we know that that's important and empowering for whatever they grow up to be. So we have 2 core messages in Spark Lab, and you've heard me say these both already. So, just this we do sort of have this repetition of messaging. So 2 really simple messages: invention is a process, and everyone is inventive. So I'll dive a little bit more into these. So this slide was intended to be animated, so hopefully even with the non-animation, I'll be able to kind of walk you through it. So if we look at the 3 pictures, you see the woman in the upper left with the glasses on, and the girl in the middle who's holding what, I'm going to move this aside, is a little vehicle. And then we have the gentleman in the bottom right who is holding what's actually a robotic ant. So those are what we might think of as sort of like, if you were here, if you could see me, I'd be doing air quotes around the world, real inventors. So these are people who have invented things, hold patents. The woman in the upper left is Stephanie Kwolek. She invented Kevlar, bullet-resistant material. The young woman in the middle is Alexis Lewis, who invented the vehicle that she has there called the Rescue Travois, which she patented when she was 12. And then the gentleman in the bottom right is James McClurkin, and he invents robotic ants that you see him holding. And these ants work in colonies to solve problems together. So these are, again, what we would consider as like sort of real or professional inventors. And that's certainly part of what we celebrate and talk about in the Lemelson Center and in Spark Lab. But we really actually want to broaden that idea about what is inventive. So inventive can be this little girl below Stephanie Kwolek, who's she's actually working on a roller coaster. So she's got, probably like a lot of teachers out there have done this activity where you take pipe insulation that is flexible and movable, and you can do all sorts of cool things with it. So she's working on inventing a roller coaster that will do something that she, complete a challenge that she has set out for herself. In the bottom center here, we have, creating iPhone speakers with a paper towel roll and 2 plastic cups. And then in the upper right, we have using a cardboard tube to plant seedlings, which is awesome because you can plant it in your home. And as soon as they sprout, you can just put them right in the ground because it's biodegradable. And then as a former preschool teacher, I love this little popsicle hack where you put a cupcake liner on the bottom of your popsicle. So if it drips, it's not getting on you, it's landing in the cupcake liner. So while we are the roller coaster and the speaker and the seed container and the cupcake liner, really, those aren't really inventions, but they're examples of inventive activity that people have identified problems that they want to solve, and they're looking around for, what do I have to solve it? And they're finding creative ways to use materials in new ways. And that's part of what inventors do every day. And so in Spark Lab, we really kind of celebrate that whole spectrum of what inventiveness is, and really try to get our visitors, young people, to connect with that, maybe looking up to somebody like James McClurkin or Alexis Lewis or Stephanie Kwolek, but also understanding that, hey, I could create a roller coaster out of pipe insulation. That's kind of within my realm. And then our other big message is the idea that invention is a process, and this is really drawn out of the work we do with looking at the records and the papers of inventors of the past and present. So on the left of the slide, you see documents that are from the Charles Brannock collection that we have here at the Museum of American History. He's the guy that invented that foot measuring device called the Brannock device. And so by looking at his papers and the work of other inventors, we were able to kind of distill the invention process into the graphic that you see on the right, and think about invention as a series of steps, not necessarily linear, but thinking about the types of things inventors do. So if we start with the think it step, that is, identifying a problem that you want to solve or establishing a need. In Spark Lab, we often kind of set that for kids, so it gives them a little bit of a jumping off point. Explore it is thinking about how other people have solved this problem before you. And we think about this as, it could be somebody in the distant past, or it could be somebody who visited Spark Lab right before you who solved the problem, and you're going to be inspired by what they've done, either tweaking it and improving it, or maybe coming up with a totally new way of approaching the problem. Sketch it is kind of obvious. There we see some of Charles Brannock's sketches, so we want kids to sketch their ideas. Create it is really a lot of what we focus on in Spark Lab. The prototyping process, try it, you're going to test your idea out, tweak it because you usually don't get it right the first time, and then down to sell it, which is, how do you talk to other people about your invention? We don't think of it literally as selling, as you might think of as an inventor bringing something to market, but getting kids to talk about their process and talk about their ideas. So it looks a lot like the scientific method or design thinking. I mean, I think it's a very familiar process to lots of teachers and students, but kind of using the invention, what we know about how inventors work, to put it into kind of a kid-friendly framework. So a little bit about what learning looks like in an environment like Spark Lab. It's different than a traditional classroom. They spend a lot of time making stuff, and here we have some kids. They were working on inventing different kind of vehicles using kind of mostly familiar materials. You can see these kids are working side by side, so they're working pretty individually, but a lot of times we see sometimes individual work as well as collaborative work, and we like to see that combination. So they're making things. They're exploring different solutions. Here's a girl getting ready to test her invention. The challenge was to invent something that could roll along that cable above the table. So we didn't define what it should look like or give any more direction than that. Just, can you invent something that will roll along this cable? And so she's getting ready to explore her prototype. Often we see a lot of collaboration. You see these kids here working together. This activity called Invent a Vehicle uses large-scale materials by design, so it encourages collaborative thinking or in collaborative building. Kids test their ideas. This little boy has put these balloons through our vertical wind tunnel and is testing it to see what happens when he does that. They are often tweaking their designs. I know they've tried something, it maybe doesn't work perfectly, so they're going to figure out ways to adjust it and make it better. This is an activity called Soundscapes, which challenges kids to build a musical marble run. And they also failed, and then, as I mentioned earlier, and build resiliency. So they're really working through the whole invention process. All of these things, making, exploring, collaborating, testing, tweaking, and failing, and coming back from failure, are all things that real inventors do in their work. And so these are they look a little bit different in SparkLab, but these are the kinds of things that are happening in SparkLab. And there aren't specific outcomes that we're shooting for in terms of a specific type of thing to be invented. So it doesn't always look exactly the same day to day or child to child, but these are the kinds of activities that kids are engaged in. So when we think about, how we develop authentic, hands-on, invention-based activities for kids that are going to allow kids to engage in the invention process in meaningful and accessible ways, we design our activities very specifically. So when we think about successful invention activities, these are some of the, requirements or criteria that we think about when we're developing invention activities. And I'm going to show you a couple of examples after this slide to hopefully make this make a little bit more sense. But so we know that successful invention activities are small in scope, so they're really focused on solving a particular problem, not trying to do 4 or 5 different things. So really focused. Probably the most important thing that we think about is the second bullet point. We want them to be open-ended and have more than one successful outcome. And so I always say there are no instructions in SparkLab. So we don't have something that says invent or build an airplane. We might have instead something that would be, can you invent something that can go from point A to point B without touching the ground? So you could certainly build an airplane to do that, to fly it, but there are lots and lots of other ways. The airplane isn't the only successful outcome. The problem is getting from point A to point B without touching the ground. We're not telling kids how that problem has to be solved. I think that's probably the most important thing, in making sure that kids are able to, that they don't have to create whatever we have in mind for them, that they can create what's in mind that they have in their mind. They're also quite playful, I think. Not always, even if we're working on serious problems, there's usually some playfulness embedded in there. They require very limited instruction. You might have seen in the previous slide that there was a woman, I'll just flap back to it. She's in a yellow apron over here, giving this little boy a thumbs up. And so we have staff and volunteers in our SparkLab actually instructing, they're facilitating, they're answering questions they're asking questions of our visitors, and they're really trying to help the visitor to make his or her own conclusions, but not saying, you should do this next, but what do you think you should do next? What if you tried, what would happen if you added something or took something away? They maybe are asking some questions, but they're never giving answers or instructing to a specific end. They mostly use simple and usually limited materials. I think sometimes the tendency is when we want to encourage creative and inventive output, we think, well, if we provide, tons of stuff and every option available, that kids will be more creative. And in fact, innovation and creativity are usually spurred by limitation and constraints. And so we think about how can we get kids to create something really innovative but also, giving them simple and limited materials. And some of the pictures I'm going to show you in just a minute, I think will illustrate that better than I can talk about it. We want them to be relevant to kids, so this could be personally relevant, it could be globally relevant, but just finding it could be relevance can look different in different communities, depending on where you live and what your experience is. Can dictate relevance. So we think we get a national audience here, so we think about what are sort of nationally significant trends or issues, but we want things to be relevant to kids. And then they allow kids to practice those important 21st century skills like collaboration, communication, problem solving, critical thinking, which, as we joke, inventors have been using since the dawn of time, so they're not just 21st century, but we tend to talk about them a lot now. So I'm going to show you now just a couple of pictures of actual activities that we've done in SparkLab, just to give you a little bit more of a visual and talk through, use these as sort of a little bit of an illustration of that bullet pointed list I just went through. This is an activity we did just recently in SparkLab. We were looking at lots of different challenges that we might have at home. And so obviously cleaning our homes is a big issue for me and probably most everybody else out there. So we were actually challenging kids to invent a new cleaning device. So the text you see on the right, we have two different, you see those purple signs in the picture. The top text is kind of gives a little bit of historic context since we're in a history museum, but kind of sets up the challenge. And then the briefer text on the bottom poses the challenge, always in a form of a question. We've realized that by posing a question, it really invites kids to feel like that their solution is just as good as anybody else's. We used to say things like invent a new cleaning device, and that was really limiting to kids. They felt like there was a right answer, an expected answer, but just by flipping it into a question, it really opened it up and made the open-endedness much more apparent to our visitors. So this was kind of a fun one. I think you can see, here's a closer up of a girl actually working on the activity. It's a really interesting combination of materials like Tinker Toys. There you can see a mop head there in the front of the picture. And then what we often do is attach, if you just bought those products off the shelf, they wouldn't all connect. So we will add connectors or ways that kids can connect things that maybe they ordinarily wouldn't be able to do. So you can see some of these, maybe a green connector there. Yeah, some different connections that allow things that wouldn't normally interface to interface. And this kind of interesting mix of materials that are all pretty familiar to kids and accessible, intuitive for how they work, but it really spurs a lot of creative thinking and innovation. And so you can just see in the text there, one day I was in SparkLab, I saw a windmill that would blow dirt and dust into a bucket, and another robotic mop because the young inventor had really bad allergies. So these are, they looked very different. They had different functions, and they were both cleaning devices, but because we hadn't specified it has to do X, or we want a cleaning device that does Y, it was really wide open and allowed them to decide what this should look like and what function it should serve. So here is an activity we did during our theme. We were looking at different community problems or issues, things that people might face in different communities, and this was creating a prosthetic hand. So again, we provided some historic context, as well as brought it up to date, talking about how 3D printers are often used to create prosthetic hands, and then we posed again a question. Can you create a basic design for a prosthetic or artificial hand? And we had many different materials that could be put together, some of which we 3D printed, so those were probably a little bit new for kids, but then other things like you can see in the purple bins, like Lego Mindstorm pieces and motors that they were pretty familiar with, so they were able to create a hand that could look any way they wanted it to, and could perform different kinds of functions. So we always try to set that sort of really open-ended challenge, and again, think about, if we can only think of one way a child is going to solve the problem, then we haven't done our job. We have to make sure that before we put something out for our visitors, that there are multiple ways they can solve the problem. And ideally, there are things that, like, usually we're surprised because kids will come up with things that we haven't even anticipated, which is really the best outcome. So then a little bit about how these ideas might translate into a game environment. So we obviously deal with like the real stuff, the hands-on stuff, but we're really excited to be working with Spark App to think about how these ideas and these concepts might translate into a virtual or a game environment. And so a couple of ideas that Tim and I tossed around, thinking about, sort of some guideposts maybe for taking an invention-based challenge and turning it into a game, is thinking about, making the challenge intuitive and concrete. I think you saw a couple of examples there that I just provided that it was very, there wasn't a set outcome, but there was a very concrete problem or challenge to be solving. And it's not a puzzle. It's really like there are many ways to solve it, but that it's not that it is very clear what you're trying to do. We focus on not scoring or winning, but we would think in a game, it wouldn't necessarily be you would be earning points, because I think in invention, there is no one right way to solve a problem. But in a game, thinking about opportunities to what we would in Spark Lab call tweaking your invention, but thinking about optimizing the outcome and solution. So perhaps there is a way to level up in a game by enhancing an invention or making it maybe do more than one thing. I think there's a lot of ways to think about that, but thinking about how we can continue to refine rather than win, if you will. And then I think you saw in some of the photos that in Spark Lab, we often provide a wide range of tools and materials to work with. And I think this could really play out really interestingly in a game environment where you could have lots of different types of materials that might be an unsuspecting group of things. So just like we might put Tinker Toys and Legos and wooden pieces all together, along with a motor or something, thinking about how that might be represented in a virtual environment, because that sort of a surprising combination of things often leads to a lot of invention and innovation. And I think one of the things Tim and I talked about is that, in the real world, those connections have to work just perfectly. So when Tim 3D prints something, it has to perfectly interface. But in a virtual environment, you get a little bit more leeway there. They don't have to exactly be perfect. And then we think that that's kind of fun. We're sort of excited to see what might come up with those kinds of interesting connections when we think about putting different types of materials together. So I think that is really all we have. It's kind of a very quick overview of Spark Lab and some of the things that are important to us and things we know that really encourage invention and innovation in young people. And a few thoughts about how we think this might translate into a game environment, but we're really excited to be in Gilbert next month and to really be on hand to see what kids come up with, answer questions, and provide expertise. And of course, we're always available by email in advance if anybody has any questions or would want to explore these ideas further.
Great. Thank you so much, Tricia. One of the things that kind of stands out to me about some of the things that you talked about is your process. I absolutely love your process, because if you look at the steps of that process, I think that it applies a lot to students and coding in general. Programming is really, when you look at it and we can kind of break it down to its simplest form, is really just problem solving.
Mm-hmm.
That's kind of what invention is as well. But I think every single one of those, every single one of those items, the think it, explore it, sketch it, create it, that's all stuff that programmers do. They do it in a different way
Mm-hmm.
than like somebody making a physical invention, but it's really the same. And I think too, a huge piece that we always try to stress to students, that I'm glad you guys are stressing too, is that everything is iterative. You're going to fail over and over and over and over again. It's that failure that you learn from that kind of gets you to the end result. Programmers have to debug stuff all the time. Students are going to be looking at their code and saying, why isn't this doing what I thought it was supposed to do? Or, whatever the case may be. So it's really great to me to see that like the physical activities actually have so many parallels with coding and coded activities as well. One other thing that I want to mention too, just for teachers that are going to be watching this, kind of pay attention to the part of the presentation that talks about how games can relate to some of those physical activities, because I think what students are going to have maybe not the hardest time, but it's something that they've never had to do before in most cases, is figuring out ways that you can take like a problem solving challenge, like what you mentioned, make something that can go from point A to point B without touching the ground, and how you can take that and kind of take that problem, but then also abstract it one level to say, now how can I make a game that teaches somebody how to solve that problem?
Mm-hmm.
We don't necessarily want students making games that solve that problem, because in code, it's really easy to make something go from point A to point B, but it's a little bit harder to abstract that one level and then say, how can you make a game that teaches somebody about inventing something that goes from point A to point B without touching the ground? Or how can you make a game that lets somebody be creative? So I think it's really important that teachers kind of pay attention to that, because in my opinion, just, from the get-go, I think that the most successful games or the most successful projects that students put together are going to be the ones that understand that difference and that are able to kind of put it into play. All right. So if anybody has any questions about what Trisha has presented or what we've been talking about, feel free to click on the chat window. If you move your mouse to the left-hand side of the screen, there's a little blue and white like speech bubble, and that'll open up the chat window for the Hangout. We also have a chat window on YouTube page as well. So if you have any questions, feel free to ask them now. I'll also give anybody, looks like we have one person, one teacher on the actual Hangout. So James, if you have any questions about what we're talking about, feel free to unmute your microphone and ask them. Otherwise, we are going to now kind of connect the invention piece and the game piece to actually allowing people or giving people the chance to use these projects or these games. So we have a guest, Christina from ASU, was going to talk about the design of these games. How do you take these ideas that we're talking about, these invention ideas and just general ideas, and put them into a project that people can actually use and that are, easy for the end user to use, or easy for people that are actually going to be playing these games to use. So we're going to take a short break. I'm going to get Christina queued up, and then we are going to pick up, and she's going to do a presentation on design. So just give us a couple minutes and we'll be back.
Switching to the other presenter now.
Okay, it looks like she's got her presentation queued up. Oh, maybe not. Maybe spoke too soon.
All right, Derek, I'm ready when you are.
Okay, great. I've got you presenting. Okay, you are good to go.
All right, well, hey, welcome to Visual Design. And I just want to say Smithsonian was on point with their design thinking, creative problem solving. That is exactly what we would do when we also not only approach problem solving and coding, it's the same thing that we would do for design and storytelling. We would approach a problem and figure out how to solve it, and we would iterate a bunch of times. So all of those same things absolutely and directly applicable to design and storyboarding. So that's what I'm going to talk about today. If we're talking about visual design, we're thinking about anything that's actually on the page, anything that's happening on the screen, color, text, characters, all of that is well within the visual design. And color is really actually the first thing that we process when we look at anything. In fact, of all of our senses, 75% of our brain is dedicated to processing visual things. And the first thing we visually process is actually color. So this has to make us, this has to be chosen really with purpose. So we're choosing our colors to make people feel things. And there's a psychology to that. So whereas art and design are very subjective, they also are very objective. There is a way that our brains are wired to process information. And when we do see color or we take in any sort of visual information, we make an immediate judgment about what that is based on the color. So color is chosen with purpose. It can make us feel things are good and evil or positive and negative. And this is going to be especially helpful in gameplay. So the colors are actually each, we're sort of pre-wired to think things about color. Yellow can stimulate our mental process, our nervous system. It actually activates our memory, and it's the happiest color. And that's why all those smiley faces are in yellow. It's also the sun, it could be heat, those sorts of things. So again, there's kind of an objective side and a subjective side, and both of those things are at play here. Colors like red stimulate energy. They can inspire action or confidence or a sense of protection, and that's why you see them on signs like stop signs. You inspire action is stop with a stop sign, and fire engines are red. They inspire confidence and protection, but also that sense of action, like pull over your car, that kind of thing. Blue is actually one of those cool colors that we associate with cold water, but in reality, if you turn the faucet on to cold water, the water itself is not blue. Same with red. We associate the red with hot, and the water itself isn't actually red. These are the colors that we associate with that. So these can be really powerful. Warm colors and cool colors give a different vibe, and they should be used with purpose. So let's talk about a couple of ways we can do that within our game design. So here's classic Mario. And Mario, we know and love him in his original blue and red. And that inspires a sense of Mario that is traditional and classic. And he's the character that we love. There's also different versions of Mario, and each time the color is changed, we have a different feeling about Mario, whether Mario is good or evil, or he's really Wario or the other iterations of Mario that happen. So choosing color with purpose to make our game players really think and feel something about their characters. The next thing that our brains process is actually shape. And so the shapes of things can tell our brains whether or not what kind of information this is, right? So the first thing our brains are processing are color. The second thing is shape. So geometric or organic, irregular, hand-drawn, accidental, these things are going to make us think something, whereas organic things are going to feel more natural, and irregular is going to feel more accidental. Geometric is going to feel more analytical, more put together, more mathematical. And so what you can do during gameplay is really match that to the feel of your game. So if your game is an invention and you're inventing things, you might be using geometric shapes as sort of simple machines, focal points and levers and stuff. And you might be pulling more organic type items or organic type things happening in the background. For example, back to classic Mario, we have Mario happening here on the left. And in this iteration, he's 2D, but he has a very 3D feel. We have that feeling because of the perspective that's happening here, the shadow that's happening, the makes him feel like a real 3D character, as opposed, and this is very organic, this is organic shapes, they have curves, as opposed to the Mario on the right, and he is entirely made out of pixels. And pixels are always squares. Squares are very geometric. And the feeling between these two Marios is very different. This is sort of classic arcade play, where this is sort of new game technology. So thinking about that when you're encouraging your students or you're developing game characters, and what is the feeling that you want? Is it this retro style, or is it more of a 3D environment? And then sort of matching that to the rest of your game in terms of characters and background and tokens or whatever it is that's in your game, kind of matching that feeling so that the environment feels very similar. Typography is really a part of shape, because at the end of the day, letters are just shapes. And so when you're thinking about putting the typography into your game, again, think about the shape of the letters. Serifs and sans serifs are types of typography, and they feel very different. A serif is the kind of type that has little bits on the tops and bottoms. And it feels very different than a sans serif that doesn't have those little bits on them. As opposed to a monospace typeface that feels very machine, it feels very computer or typewriter. So again, matching that into the feeling of your design. Or do you have more of an organic theme kind of going, or do you have a very mechanical? If I was going to go mechanical, I might go with the geometric shapes, and I might go with a monospace typeface to kind of bring that around. Right, all of that color and shape gets put together, and here's two different iterations of Super Mario, and they feel very different. Even though they have similar colors, they're saying the same thing, the way that they're presented is slightly different. So all of those things, color and shape, can kind of play into that. During the competition, we'll be providing you teams with design assets, and I'm going to show you ones that we used last year so that we don't reveal the surprise of what the theme is for this year. But design assets are anything that you're putting in your game. So your characters, your background objects, your towns, your cities, whatever it is that you're putting in here. And last year, we had a very Hack the Earth, Save the Environment theme. And so these were our eco emojis that were design assets. So you can see these ones were very pixelated and had a specific, they have a feeling of that kind of geometric and sort of retro look about them. We did present them in several different colors, so you can see the difference between sort of the more natural colors you find in nature, the greens and blues, as opposed to the neon colors feel very different. So you can imagine the story building around them starts to be a little different, as opposed to kind of these muted colors. It feels different, even though we're looking at the same assets there and we're looking at the same shapes. They are different because of their colors. These are some of the VIP emojis we used from last year, including an eco emoji of the mayor and ASU's President Crow and Fulton Schools of Engineering's Dean Squires. So look forward to seeing the unveil for this year's assets and this year's themes. So when we're thinking about gameplay and we're thinking about the design, we want to also think about our story. It's really visual communications is really just storytelling. And so the first thing to think about is, who is your characters? What mood do you want to set? And what color, shape, and typography might be used with those characters. And this is a technique that we call storyboarding. Storyboarding is exactly how we're telling the story. It could be very much take the shape of like a comic book. So one thing that we do to kind of get the ideas out of our head is called mind mapping or brain cloud, that sort of thing. So you want to get the thoughts out of your head, and you want to just think about every possibility that could be out there for making a game or doing something, solving a challenge. So you just get all of the thoughts out of your head, all the possibilities, and they don't have to make any sense together or string together in any way. You just, anything that pops into your head, you write it down. You write it down, all of your possible ideas, and don't worry about if they're good ideas or they're bad ideas, or if the ideas even connect to each other at all, because the second step after you get all those thoughts out would be to start connecting them. Okay, I wrote down all of this stuff. Now let's try to sort through it and find out, how does it even fit together? Does any of this stuff actually fit together? This could very much so take the shape of sort of a brain cloud or a mind map, where you write down sort of game ideas or something in the center, and then you start to branch those things out. What does that mean? What colors are those? What feelings do they have? Are these characters good or bad? Where is the setting to this story? That sort of thing. When you're brainstorming, you really want to answer the essentials: who, what, why, where, when, with who, how, and how much. That's a lot of questions to answer, but if you think about that, who, and you brainstorm all the different possibilities of who could be playing your game, or who is in the game, and what are they trying to solve? What are the classic things that are solved in games? Is it saving people, or is it collecting coins? Is it achieving some sort of goal? What is all the possibilities for that? All of those things get thought about in your brainstorming, and this is really research. Brainstorming is part of our research, and brainstorming in games would be looking at other video games, looking at competitors that you have out there, but then also taking a step back and saying, okay, video games, yes, let's look at those, but let's step back and say, what about board games? What kind of board games do you have? What kind of board games do you like? And what happens in those games that you like and don't like? Thinking, again, another step back, more abstractly, what about TVs and movies? Essentially, we're doing storytelling with our gameplay, and storytelling could be something you saw in a TV or a movie or a book, or even just daydreams that you have. And all of this brainstorming is research. When you're looking at all of those things, you want to take a look at, what do people like about those things? What do they like about board games? What do they dislike about board games? What do you like? When you're making your game or anything, if you're enjoying it, if you're having fun with it, and it's something that you would like, it might be something that others like too. So thinking about other games, video games, board games, TVs, movies, books, what are the things that you like about them, and what are the things that you dislike? So you might, in your game, employ the things that you like, and then take those things that you dislike and make them better. How can you turn it around to take something you dislike about something else to make it something that you do like? Games is very much so like storytelling. Here's our classic Pac-Man interface, and it has all of the same assets as storytelling. It has characters, it has Pac-Man and the ghosts. It has a setting, which is this game board, this sort of maze. It has goals, which is to collect all of the pellets. There is a time that it's in, not only the time frame of the game itself having a time limit, or actually the time period that the game is taking place. In Pac-Man, that isn't as relevant, except for that we do have that retro style that tells us that it's happening in the past. It has tools, so Pac-Man has his tools of his super pellets that give him superpowers that allows him to eat the ghosts instead of the ghost eats him. And then tasks. So the task at hand is that Pac-Man needs to get all of these dots and then needs to get to the next level. So it really is storytelling. And if you think about the games that you really like playing, there is a storytelling element to this. For that reason, we can actually use a story map to help us tell the story of our game, to help develop our game. So in a story map, you could write down the setting, where, when, main characters, minor characters, what's the problem that they're trying to solve, what tasks do they have to do, and what's the outcome that we're looking for, whether that's to win the game or to solve a problem or some other sort of challenge. Storyboarding could be a sequence of sketches. It could be what will the players do, how will they do it, and what the player is experiencing. So we're really diving into the see, hear, touch, even taste and smell of what's happening in the game. And a storyboard happens something like this. So very much so like a comic book, in which you might draw what happens from scene to scene or during the process, where the game starts and where the game ends, and write down a few words on what happens there, what the character is trying to do. This is going to go through several iterations. You might change your mind. You might have several different outcomes. There might be several different pathways, sort of a choose your own adventure. If your character goes into the dark cave, you might have a certain set of outcomes or tasks that would be different if the character chose to stay on the path, or to fly an airplane or dig underground. There might be several pathways, several journeys, which would result in different tasks and different outcomes. And this is a great place to kind of visually kind of put that out there. So thinking of the game story, who's playing, what do they want to do, and how will they get what they want, and what stands in the way. So all of these go into your story. And you don't want to forget your audience, which is going to be your peers, who's playing the game and what things that they might like. And that is what I had to talk about for design and visual storyboarding. And I would be happy to take questions if there are any.
Great. We'll leave the group chat open. And again, on the YouTube page, if you're watching live on YouTube, we also have a chat box on there so you can ask any questions that you'd like. I just want to point out, though, I'm really kind of fascinated by how many parallels there are between the invention presentation that we saw earlier and the design presentation we just saw. You know, one of the things that I see at every Spark competition that really the students that typically end up being near the top and in most cases end up winning are the ones that do the storyboarding, or as the Smithsonian people said, the sketching. So the people that, instead of coming up with an idea and then just jumping right into it, the people that come up with the idea and then plan it out, they either draw it out in advance or think about what is going to be the best or easiest way for somebody to actually use this game or this app or whatever it may be. Those students always have a better end product or a better end result. We always see those students as the ones that are winning the competition. So as much as this is a coding competition, it's meant to teach students what the coding process is like. And it's not just, I have this idea, I'm going to write the code for it. It's, I have this idea, or there's a problem that I need to solve. And then this is kind of how you go through that. So thank you so much, Christina, for giving that presentation. For those of you watching or that will be watching this later, Christina is actually going to be in the next 2 sessions as well. So if you have any questions at all on design, you know, she'll be available to answer questions that you have as I'm going through the rest of the Scratch tutorials and kind of going over some of the game design, problem solving, puzzle solving things. So if you do have questions, again, feel free to leave them in the chat or leave them for us on YouTube, and we'll get to them you know, as soon as we can. If you don't have any other questions right now, or nobody has any anything else that they want to ask or go over, then that is it for our teacher training session for today. Tomorrow and Thursday, we're jumping back into Scratch. So we'll actually be jumping back into code, and we'll talk about how to actually make a basic game so that you can kind of see some of those other pieces of logic that we were talking about in the previous sessions. If you haven't checked out the previous teacher training sessions, I would highly recommend doing so. We have all the videos and everything published on our website. The address is here on the screen right now, sparkappleague.com/teacher-training. We have every single video from the teacher training sessions that we did, along with links to the sample projects that we made in those sessions. So you can break them down, see exactly what each of the code blocks looks like, and how that ties into the end result. And then I also have the homework assignments listed on there. So each week we've given teachers a homework assignment at the end of the week to kind of see if they can figure out how to take what we've taught and extend it further. So highly recommend that. And then also on our website, you can contact us. If you ever have any questions, this page also has links to our contact page and our Slack chat channel, which I am in all day from 7 a.m. to 6 p.m. So if you have any questions whatsoever, I can answer those on there as well. But that is it for our teacher training session today. Again, join us tomorrow for the next session where we'll be jumping back into Scratch, and we'll see everybody tomorrow. Thank you for joining us.